All
Hello,
right,
everybody.
we are live.
Yeah, episode one. New to this, so let's see how it goes.
Yes, yes. We are super excited to be here. And thanks for everyone for listening wherever you are or whenever you are. Uh, why don't we do a quick round of intros, Avya?
My name's Avyay. I actually studied economics, finance, and math. And then now I'm going to be doing data science. And I don't know how I got into the tech world. It was mainly through, healthcare and how we pivoted into AI and trying to incorporate AI into the healthcare business, which my father had started, and that's how I got introduced to Sid, and we started working together, and now we're here.
Thanks. Yeah, and for me, I'm an old fart. I'm his dad's age, but I don't feel old. But I'm certainly, all of us are new to this whole AI world. I think everyone's a noob. Nobody's an expert unless you've been in, AI for decades, which some people have been. But that's not us. So I'm a software engineer. I've been, sort of in the IoT world for a while, but also we do a lot of generalized software consulting. We did some mobile apps. We build platforms, and I think since I would say what November of last year, Javier. So
Yeah,
November
since
2024, we've been working together, Javier and I, just banging our head against this this amazing new platform and technology that is taking the world by storm, and making some breakthroughs. Just I think every we have this thing where every Friday we have a breakthrough. We have been over the last few months.
touch wood, it keeps going.
We had some weeks where nothing happened. We were just struggling. We had our hearts broken by various technology darlings, which we'll come to in a few minutes. But we think we've landed in a place where we feel at least we feel like people can learn from our experience and maybe hopefully not make the same mistakes we did.
Yeah, I think our journey's really been like, just figuring it out as it goes because there's not much on the AI world out there. Everything you read these headlines and you see these models coming out, but you don't really know what it takes to get to that stage and what they're actually doing and how this engineering is working. You see all these headlines with they're paying nearly $1 billion for somebody to engineer an LLM, and for us we actually kind of dug deep and tried to find exactly what it was that kept us going, and in this AI space, we've actually started not knowing much, and we discovered a lot of it. And I think we didn't really read much on it. It just came to us as we were doing it, and we understood more of the nuances and what it takes to actually build something
Yeah,
from not knowing anything.
yeah, yeah, absolutely. And I think our approach, the reason why I think it's been a fun ride for me, doing this with you, Avya, is that we've had a very non-judgmental approach when we came to this. We were not hard on ourselves. We didn't really give ourselves any timelines. We just said, look, let's come to this with an open mind and not be prejudiced against one type of technology or the other. And we, again, we had some frustrating moments. We took some very, very strange left turns somewhere or the other. But I don't think, I think we followed this model of slow but continued progress, which I think in the end really helped us get to this right place. We didn't put any pressure on ourselves in terms of this has to be done by today or tomorrow or next week, because that's what everyone was doing. Everyone was just rushing to build prototypes and MVPs, and it's all well and good to do that. But I think what I've found is people were able to find a lot of initial interest, and then nothing really, the unit economics didn't pan out. Like, we'll come to that in a second, but just pricing was wrong. Support from these big platforms was missing. Um, the promise was there, but just when it actually came to building something that needs to work, uh, the promise just the last mile was missing, or the first mile was missing. So I think we'll come to that. We're going to cover a few some ground today on that. I think that's what I'd like. That's what I think we should focus
I
on.
think a lot of it was also that us not like really getting stuck in one way. Like we were very open to trying things, and nothing really discouraged us much. Like because I think the key was that we actually didn't stop. Like, no
Yes.
matter what it came to, we were trying to find something new or we discover something new and we were just at it. Like, even if it was small, there were days where nothing went right. Like, there were
Yes.
days like where we went
There
like
were
four.
weeks. There were weeks like that. There were weeks
And then
like
there
that.
was like a week where we started from scratch because we were like completely stuck. And, it all started with like just trying to build this data pipeline. And we were just like, okay, let's go into data and let's see, we have
Yeah.
all this healthcare data, health care related data and what can we do with it. And that's how the journey really started. And then
Yeah. Yeah.
that's
So
that.
should we? What are we doing next? Are we gonna go? Should we jump right in? Are we talking
Yeah,
about
let's
our
let's just
story?
talk right about Databricks and how we got
Awesome.
started there. So I think
Yeah. So
that
I think let's start at the very beginning. So we started working because the company that is working or was working at the time is a company that was started by Rahul, his dad. It's called Vesta, and it's an amazing product. It's a home healthcare aid provider for folks that require for aged, but also people who are sort of compromised in some way or the other. They need people, humans, to help them with their needs. Think of dementia or other conditions like that. And Vesta has been has been in operation for many years as a provider of home health aids. And we were sort of brought in, or at least I was brought in to help them uh, add a uh, add a tech angle to the or an AI angle, which was a very very vague description or very open ended description, but just essentially create a tech enablement angle that would leverage all the existing data that was available, going back into 5 years of matching data, and we'll get to that in a second. But I immediately, because for two reasons. One was my nephew had just my wife's nephew had just started working at Databricks. I was sort of enamored by them. And last year they had been very, very heavily sort of pushing, in conjunction with the deep learning folks at deeplearning.ai, really pushing this whole concept of data engineering and how, data pipelines are, everything is a data pipeline and everything just works. And you have to come to Databricks because we are sort of we are going to be the AWS. That's what I thought at the time, at the very least. Because, I mean, obviously, I'm an AWS user. Everybody who's in software knows and loves AWS because of their attention to detail and how they allow you to scale up or down your costs, and they don't treat you any different. So fast forward to about 3 or 6 weeks, I would say, like, we spent about, 6 weeks, and we had some great initial success, and we should talk about that.
Yeah,
So I
we
think,
built quite a lot of we like actually like initially uploading all of that data and for it to actually recognize the data and sort it into tables and everything was quite it did it very well. Like, it saved us a lot of time trying to sort through it. It helped us clean up the data and their actual assistant which it actually helped us get a lot of those values clean. So
yes,
we got the actual data we needed. So to their
yeah.
credit, they did have some kind of use cases for us right at the start. But and we
Yeah,
did.
I think what they really excel at, because that's sort of their thing, right? I mean, they've been around for 7-8 years now, and the thing they do really well is data pipeline, or what they call data intelligence, which is sort of the next level, which is basically allowing you to very quickly ingest, you know, tons of unstructured data. In our case, it was not even that much. It was maybe an Excel sheet with, I don't remember how many rows our Excel sheet.
45,000 or something.
It was
40. It was,
45,000 rows. I mean, which is, again, seems like a lot, but it isn't for these kind of massive relational database systems. But what I was really liking about it was the whole integration they had. They had an assistant, which we'll name later, but we used to think it was a very smart assistant back then. And uh, we got used to sort of, I certainly got used to, I'm not a data scientist, but I started to really start to, you know, fall in love with the whole Jupyter notebook format where we could have in a structured way talk about what we were doing and then execute code and all that stuff. So really fell in, there was an early romance that was blossoming with Databricks that we really liked. We got to a point where we were doing machine learning, and we were coming up with what's called a matching algorithm. You can talk about what that matching algorithm is. Avyay.
Yeah, so what we actually did at Vesta, I'll give a little bit of background on why it was useful for us. So in Vesta, we had actually a telecalling team who used to, the clients used to call in and speak about their ailments, and we would try and find them a caregiver. So we had a telecalling team, and then we had an operations team who would handle, finding the caregiver and all of that stuff. So the telecalling team used this sheet that I had created. It was called a call record, and I'd put a bunch of Excel formulas into it, and to make it as close to a CRM as possible. And what it was basically categorizing the leads. So if a lead was cold, if it was hot, if it had some potential, if it was a repeat query, and we had systems to identify all of that. And what we wanted to do is actually identify if at the early stages, if a lead could be qualified in that sense as something useful just from that sheet, right? Without hearing any of the transcripts or anything. So it would allow us to actually go a step further and empower the telecallers with, useful data that these are the leads that you could have converted. But then, when as we started working on it, we realized that, okay, there isn't enough data on that sheet for an algorithm or a model to actually be able to give us a decent output. And we did that. We trained the model with that data, and we saw that okay, it was giving us a response, but it didn't have enough information to basically classify just on the query whether the person was a prospective client.
Yeah, and I think what we discovered was that there was just not enough data for us to come up with a model that was providing results that were useful or reliable, right? And we first we thought that there was a problem in the data itself, but it turns out that there just wasn't enough data. So we did something. Well, you suggested that we synthesize data, which we did, and lo and behold, it actually worked, right? So we were able to actually come up with a matching algorithm by essentially synthesizing what 8 to 9 times the amount of data we had. It was a
Yeah,
pretty big number, right?
yeah. So what we did essentially was one step before all the synthetic data was we actually had to match, So we have the clients who got converted, we had the converted data, and we had the caregivers, and we had all of this data together. And the first thing we did was put it all into Databricks, and we kind of organized it, which Databricks did help us a lot with, right? So we got cleaned up quite a lot of the sheets, and a lot of it was actually not only Databricks, but we actually used GPT
Hmm.
quite a bit. I use
Yes.
GPT to clean up the language, to standardize most of the queries, because at the end of the day, it was human input. So there was, ways where there were some spelling mistakes and everything. So till first we organized the data, then we put it into Databricks, and it worked a lot better. But the main thing was when we got the matching results, we didn't have enough. So what we did was we duplicated them and quadrupled them so that we would have enough data. And what we found was that actually, if we gave it the same data but multiplied, it was actually giving us better results, and it was actually training the model better. So it
Yes.
wasn't actually that the quality of the data. Sometimes it was just that there was certain things we didn't understand was why it required so much data. Where even if we gave duplicate, it was giving us the same thing, and why it was getting trained better with more duplicate data. So maybe it isn't actually about most of the models aren't really training as much on quality as they are on quantity, because the more they see patterns, they probably recognize them easier. So that's what
Yeah.
actually gave us a great matching algorithm at the end of the day.
Exactly. And I think that was those were heady days because we had made some amazing progress in just like 4 to 6 weeks. I remember it was just it was still early December. I think we had started in November. It was around the the end of the year. I had to take a few weeks off. but we were literally very charged up by the fact that we have a matching algorithm. I think it might have been end January around
Yeah,
that
it
time.
was just moving into Christmas because I think you were traveling and I was traveling,
Yeah,
and we were
yeah.
just we were talking about.
We went into the holiday break feeling very, very good. We were like, oh my God, this is great. It's an interesting platform. This is the darling of the media world. It is really amazing. And next is going to be, so I think the next charge we were given was, this whole idea that, can we build a chatbot? Because everybody is building chatbots. I mean, they're not, agents is 2025's, term of the year, but last year was just about Q&A and, pipelines and RAG pipelines and things like that. So we decided it's time for us to build a RAG pipeline. A RAG is just retrieval augment generation, where you essentially you assist the LLM in its responses by giving it chunks of data from that have been retrieved, which is by retrieval. You augment it, the response, by giving it retrieved chunks of data from from some data, from some existing data that you have uploaded, right? So mostly it's documents. So the requirement was that we needed to build an intelligent chatbot, or an agent now that would at least initially answer queries about just basic things about what kind of caregivers can Vesta provide, what are their capabilities, what can or cannot do, really simple stuff. And the reason here we wanted to do this was that the idea was that there would be an SEO optimized landing page that Vesta had, but there was a lot of traffic coming in, and instead of having people fill out a questionnaire, they could literally just talk to a chatbot. So that was sort of the vision here. And yeah, and so we sort of really started this saying, oh yeah, Databricks, we'll just do it in Databricks because Databricks is pushing their data intelligence platform.
And we
And
really
we got, yeah, go
and
ahead.
we really thought it was like, it was going to be our one platform, and where we could build a product on Databricks itself, and kind of keep
Yes,
it there. And a
yes,
lot of the reason that we went into RAG was because, okay, even if you put a document into LLMs, until you are giving it that chunk and actually using a RAG pipeline to get the answers, there will always be hallucination, right? And we wanted to bring it down, especially when we're dealing with medical terms and medical
yes,
data and instructions about services which are very, let's say, sensitive. Like, it's a very sensitive piece and it's to a loved one, or it's somebody, it's your family member, and it's elderly people, right? And with that, miscommunication can happen very easily. And so we wanted to actually make it as tight as possible, and especially with medical data, we wanted to try and fix it so each question was answered to the T. Like, there was
correct.
no room for error, there was no room for interpretation. And as we know, what we found, like, if even anybody uses ChatGPT today, you can say that, am I the king of the world? And it'll be like, yes, I'll agree with you. There is that psycho.
Psychophancy, that is what the big term is these days. And apparently they've reduced the psychophancy of ChatGPT 5, which a lot of people actually don't like anymore. It's become a lot colder for them. Anyway, we won't get into that. But the interesting thing about all of this, and you're absolutely right, was that we needed to have zero hallucinations. We needed to have answers that were direct. But interestingly, we had just two documents that we started out with. We had an FAQ, which was really just it's the standard thing that used to be there in all
In all,
websites, right?
yeah.
Any sort of business that, especially a business that's providing a service, always has an FAQ section. So we just literally created Avyay and the ops head just created an FAQ which had I don't even remember how many questions it had in
I
it.
think we had about 40 questions in it.
Yeah,
And it
40
was mainly
questions
it was
answered.
mainly to do with, general stuff, like,
Correct.
general things people would ask, and things related to services, like general
That's right.
FAQ, which was the we kept it more to the caregiver thing because we were coming to the next document, which is the caregiver job description and
Yeah.
roles of the caregiver. So it was actually aimed at first trying to, we were just prototyping it to see that, can it actually take the role of what our head of operations does, or, head of
Yeah.
the face of actually the customer facing side of the team does, where, they speak in the customers ask these questions a lot. The first thing they ask is, what can a caregiver do? And,
Yeah.
that became our prompt to test a lot of things in over time.
Exactly, and we were so enamored. I was certainly with Databricks that we said, okay, we're going to start a new day. We'll start a new Jupyter notebook. It's going to be called. We had we were following the terminology to a T. We had our own catalog. We had our own space. We were even using some of those. We were really gung ho about Databricks at the time, and we started obviously with the assistant, whose name evolved slowly. But we found over time that the answers it was giving, there was a lot of hallucinations. The code it was generating was not that great. It would generate snippets of code for us, and arguably this is like early this year. So asking a reasonably good coding assistant to build a RAG pipeline, especially one that's actually in Databricks, where we've already done a lot of the work. We've ingested the Word documents; they're available. They're part of the catalog. The data pipelines about to be set up. We were disappointed on two fronts. One was basically the code would get generated, then the Python wouldn't run, the code wouldn't run. Then it would suggest fixes, but the fixes were just stupid. So I think we started calling it the Mundu, which is a Hindi term.
And a lot of the reason we were actually using the AI assistant was we were actually trying to make it easier to build. So like for example, we were trying to replicate it, and the thing was we were trying to simplify the code, and for example, trying to basically build a step-by-step guide on how it could be done for like
Correct.
if we had people working with us, that what was our journey. That's why the Jupyter notebooks were helpful to us. That's why we're using the assistant so much, even though we could have written the code ourselves the whole time, and it
Yes.
would have saved
Yeah,
us a
yeah,
lot.
yeah.
It would have saved us time, to be honest.
It would have.
It was just for replication. Like we were seeing what the actual capabilities of the LLMs were, and we had to
Yes.
stress test certain things, because if we are going to recommend this platform, and if we are going to help other people build this way, we had to see what limit their actual own LLM did
Yeah.
have. And what was shocking to the point was why we started calling it the Mundu was because it actually had less knowledge of what Databricks was offering than GPT 4.0 at that time. And that
That was
time,
shocking. That was one of the most shocking things. I remember when we realized that it actually knows less about Databricks than GPT-4 does. And GPT-4 hadn't even come out with Mini yet. This was
no,
just
the
GPT-4.
and the in the O4 mini models, it just O1 had come out at that time, and
Yeah,
it was 4.0 we were using, and
yeah.
4.0 was the legacy model, which has actually been the best for OpenAI, in terms of building their image and everything. And we were just at the basic model, and that basic LLM was actually doing so much more than an LLM that you have to pay for. Like the assistant, if you're on Databricks, you're paying them. Like it's not free to be on Databricks at any point.
Yes, yes.
So,
Nothing
so
is
it
free
is.
with Databricks. And yeah, and
That's
I
a big
think,
point. Like, nothing is free with Databricks, like being anything. There is no free trial. So as soon as you start putting things in, you need a credit card, and you
well,
need to start.
and I think we were willing to basically bear the pain because a lot of the elements, by the way, they designed it so that, as long as we don't have, they do everything inside the Jupyter notebooks, and you have to have this, I forget what it's called,
Cluster.
effectively
We were
like
running
a,
a cluster. It was
what's
called a
that?
cluster. We were running the cluster, right?
Yeah,
We had
you need to basically turn on a cluster. So we were extremely, extremely judicious about keeping the cluster switched off and only running when we were actually, using it. So our hour of usage was maybe like 3 or 4 hours, maybe 5 hours a week tops, right? And our billing at this time was basically in the 10 to 15, maybe $20 range, which was acceptable.
which is
At
very
the end of the
reasonable.
day,
So
it's quite reasonable.
for our work, what we were doing, and the
It
amount
was
of
fine.
ease it was
Yeah.
reasonable. Yeah.
And then fast forward a few days, we had already decided that the assistant was really just useless. We were calling it the Mundu. We would barely use it. We had literally two tabs open. We had
You had a lot of
Databricks.
faith in it, though. You'd still go back to it from
I go
time to
back.
time. You're like,
Yeah, I know. I was a little bit more. I was more of a indulgent parent in it. In my, I guess it's my parenthood training, which is saying, look, let's give this guy a chance. Maybe he's had a bad day. But I think by the end of it, we had stopped using the assistant. It was just a mute spectator. We had one tab open with GPT, and we would literally get all of our answers. We'd cut and paste and code from GPT. All the errors were actually being put back into the GPT context window, and that's how we were developing for a long time. And it took us about a week or two, really, just to basically get the RAG pipeline done. We obviously it's fairly straightforward now. With hindsight, you know what you need to build. You have to create chunks. Then you need to create a vector search endpoint. Obviously, all this stuff is super easy to do inside Databricks. It's
Databricks made it
designed to
so
help.
hard for us to find it. Like I'm saying, by this time, O4 Mini had come out, and we discovered the model. Like I was using it, and I was like, the thing with actually just a little bit of a diversion, but like O4 Mini and O4 Mini High, like those models were actually so good because they were intuitive. Like like I
Yes.
like, and there was some benchmark Future Plus or something. The benchmark came out, and it said that these are the best models for predicting what's going to happen because they were very human like. Maybe they didn't
Yeah.
score well on leaderboards and stuff, but they were very good to use. Like whatever we found, like O4 Mini High for like coding and general reasoning with O4 Mini, it was just, I found it very good. I think you did too. Like I think those were our go-to models. We didn't use
Yes.
any.
Absolutely. I agree. I think those were truly amazing. Times we really started to get into a flow where I felt that O4 Mini High was just could almost read our mind. It would give us exactly the thing we needed, nothing more, nothing less. The hallucinations were very few. But again, we reached a point where we got what we wanted. We managed to create a vector search endpoint. And again, we would switch off the cluster at the end of the day. But I think it was about, towards the end of March, I remember this was happening. And the March bill jumped from like $15 to $250. And I was shocked. I said, what happened here? And,
And
first of
luckily
all,
we caught it
Databricks.
fast enough. We caught it fast enough because you caught it. You caught it fast
I
enough.
got it because I would get the bills, and I had this agreement with your dad that we were playing around with Databricks, and as long as the billing is under 100, he had said, yeah, go ahead and do it. I think it's fine. That's within the budget. And I was shocked because we hadn't even actually
We
rolled out an
haven't
engine.
prompted it once. We had done
We
nothing.
didn't even
It was
talk to it once. And I think the reason it was painful was we didn't even have, we were able to very quickly get the data side of the data pipeline done. We got the vector search endpoint done. When it came to basically standing up an API or even a front end, Databricks just was not being helpful at all. There was really nothing we could do that was easy without leaving the platform, right? So for me, the
yeah.
biggest shock was Databricks is sort of calling itself and is positioning itself as the data intelligence platform. Yet, for someone who's just looking to build a simple Q&A chatbot with a pipeline, just a RAG-based pipeline, right? Uh, Getting those last three pieces of the puzzle, which is the API and a front end, was proving to be very, very difficult. I mean, it was not obvious at all. The assistant was completely useless. GPT was helpful, but I think there just wasn't enough, good tutorials on Databricks. I
And
mean, I think I must have
Databricks
studied.
own their
Yeah,
own resources weren't helping us. Like
they
we
were
went
not
through
helpful.
all of them. We went through the
Yeah.
academy
Yeah.
that, and it took you so much time to actually get access to those resources.
Yeah, and I remember at the time we had to basically they had these Langchain, they had these Langchain modules that they were obviously everyone uses. I mean, Langchain is definitely, I would say, the de facto way of building sort of any type of,
Anything, anything.
Q agentic or Gen AI product. It's very very especially if you're in Python. So it was great, but then what I found amazing was even the stuff that was designed to work with LangChain was not working quite the way we wanted. So we were just always like 1 or 2 days or 1 or 2 steps shy
And we
of
kept
having
trying
what we
different
really
things.
wanted, which was just a bloody front end that lets you ask the question, which was so frustrating to me. And in the middle of all of this, this bomb drops, and we get this bill for $500 or $250, and
Which was crazy because you know what the funny thing was, we'd configured the vector search to not work, and what it was Databricks had it so it had to always be on. There was no option to turn it off. Like even if you weren't calling it, it was calling something, which was so strange because I've never seen that before, and neither did you. And we tried everything, like we tried everything to turn it off. We turned off the cluster, deleted things, got rid of things, and it was charging us like
well, I mean, it charged us for I was we were basically being charged about, I don't remember what it was, 15 or
it was
twenty
thirty
dollars a
dollars a
day,
day or
and that
something. It was thirty
$30 a
dollars.
day for about, and that went on for about 10 days or 15 days, which is why our bill went up to $300. We obviously at the end of it we turned off everything, we deleted everything, And of course, the billing went to zero. But what I found shocking after that was what happened next was even more shocking. That's really what basically completely soured me on Databricks, which is that when I tried to contact support, I didn't hear back from them for 2 weeks. 2 weeks, okay. And then the response I got from them would push some of our Indian, in some of the worst Indian departments to shame in its sort of complete lack of, completely tone deaf. The response we got was literally, I kid you not, I can probably quote it from here. I probably still have it in my email inbox. It said, we cannot give you, because I had said, look, we accidentally turned this on. We didn't realize, even though it's your fault. I didn't even say that. I said, look, we were not using this vector search index. You can see none of our clusters are running. This is just a vector search index that's never been used. But that just because there's a vector search endpoint that we created, you charged us for it. Is there a possibility that you give us these back these credits because we've not used the product enough? This is the response we got. The response we got was, because this is not our fault, there's nothing wrong technically with our product, we are not going to give you anything back. Thank you very much. Have a nice day. So at that point, I realized, and I
Sour,
think
yeah, it was a sour response.
at that point, I realized that they are really not catered towards, companies that are just looking to keep, firstly, $100 to $200 per month budget, and two, small companies that are just looking to try this product out. And frankly, I feel like they've probably lost me as a customer for life, because this is not the kind of stuff that you overlook easily when you're trying to look at the. So short-sighted of them, because if they want to be Google, or even if they want to be Oracle, or clearly they can't be the next AWS. You have to be obsessed with every size customer, and they're not. It's very clear. Maybe because they're growing so fast, they just
They,
have hyper growth. This is what happens when hyper growth happens. You basically only focus on high value customers, but that's a short-sighted approach. Anyway,
yeah, we were
that's the end of
discussing.
the Databricks chapter.
Yeah, no, it was done. But I'm saying that the thing is that creating an endpoint doesn't mean it's always being called, because we weren't calling it at all. And that's the thing. Like, there's nothing at that endpoint and we were getting charged. I just
Yeah.
saw it and it was $50 a day. And, we turned it off in 6 days, and then it rolled over. That came in two bills because the billing cycle changed. We,
Yes, I remember. We got two bills, which is why it broke the. I mean, it was a little less painful for me, but I mean, I still had to go and tell Rahul that this is what's happened. He was obviously extremely well, understanding. But I think what that ended up doing was it really forced us to stop being a consumer and really go deep. I think in many ways that was a good thing that happened to us, because that forced us to say, okay, let's go back to first principles. Why are we trying to basically use ChatGPT's API and putting in these API tokens and then just being within this platform? It was more of a aha moment that said, okay, maybe we can just build this on our own. This stuff is so new and it's still evolving, that the right thing to do maybe is to just roll our own. So we started
yeah.
down that path, and that was really another really amazing period, because we were still, O4 Mini was still around, and it's truly helping us a lot. And we said, okay, we're going to basically run this on an EC2 instance. I like AWS. I've been using them for a long time, and
They
we
were
made some
reasonable.
amazing progress.
They were reasonable, yeah. I think the main thing was, yeah, when we moved on from Databricks completely and went into, doing different things and trying different things, we we just said, let's open Cursor, which was great. You started using Cursor and we started talking more about, all of these different coding agents in a certain way. And Cursor, basically, we actually didn't really use many of the Cursor's functionalities, right? We were just basically using the playground to build in a way and look at our code and run it easily. And the main thing was that using EC2 AWS, and we were using Llama, the 7B, Llama 37B. It was a 7 billion parameter model, and we were trying to. The thing is, the first time we were building it, it actually took us a little bit of time, and the intricacies were actually mainly with the quantizing of the model and
Yes.
getting it all done. And after that, it was pretty easy. And I think Langchain, to that effect, is great. Like, it was great, and we it didn't take us long. It took us, I think, a week to get it all up and running.
Yeah, no, Langchain is amazing. I think Ollama and Langchain are the two, I would say, key building blocks that I have come away with as saying, look, if you're building anything, whether it's rapidly prototyping something, building an MVP for any customers, these two tools should be sort of your screw and your hammer. They are the two things you need, and you can pretty much do anything with it. Langchain obviously is has become huge because of how easy it is. Just everything's just an import. It's got such a huge amount of libraries available. You can now it has integration with MCP, so you can do a whole bunch of tool calling inside LangChain. So I think with and Ollama is to me like basically just Docker, right? Like it's so easy. You literally just install. You pull a
Model
the
with
Ollama
its
library. You just
embedding.
pull
Yeah.
one of these LLMs. You don't have to worry about building it. You don't have to worry about the tensor format. Like we did all that. We actually downloaded Llama CPP and we ran the quantization code.
But
And
we
all
did
that
all
stuff.
of it manually. That's the thing, that we knew how to do it manually, so we understood like the benefits
Yeah,
of Olama, right?
yeah,
The thing is, the whole journey in a way, like now we look at it in hindsight, and it's like we know exactly what to do. But like when we were on it, like because we did all of that, we understood the value of Olama, and at that point, when we pivoted from actually getting the RAG pipeline working to actually finding Olama and Langflow at that time. We'd gone to Langflow because Langflow
yeah,
just let you connect things like Legos and make all of these different kind of
yeah,
flows for agents. And you could quickly prototype agents. But what we found was, because it's actually owned by IBM, and we'll come to that a little later with what intricacies that had. But the thing was, we said that it's not for us, and Sid and I decided, we were like, okay, I don't think I think we're wasting a little bit of time here, because they are asking us to connect a different database and everything, and we said,
yeah,
let's just do LangChain because Olama works great. So let's just get Olama and work with
yeah.
LangChain and get it done, and we got it done
The
pretty well.
same. I agree. I think this the reason we sort of moved away from Langflow, at least personally, and both of us had the same feeling, was that they were trying to steer us towards IBM products. They have this Astra DB, so they were saying, oh yeah, it's open source and it's low code, no code, but it was a little too
It was a little too low
still
code, no code.
exactly it was exactly, you took the words out of my mouth. It was a little too low code, no code. There was too much of a sharp learning curve, and because I'm pretty good at coding, I'm a native coder, I actually went back to LangChain. So for someone who's not comfortable and familiar with Python, maybe Langflow is the answer for you. But like if you're like most people and can sort of code reasonably well, the Pythonic idiom, most people do, but you don't have to be an expert coder. You can just sort of, you can follow along basic
And
Python.
and we found
uh,
that these coding assistants like GPT, even like the new GPT-5 thinking model, is actually kind of decent from what I found. But they will actually walk you through a lot of this stuff. Like, they can, you just need to know how to audit the code. That's the thing.
yes,
If you don't understand how to audit the code, that's where you run really into a big problem, because it will work great till it doesn't.
yes, I
Debugging is
agree.
what debugging is what you need the coding knowledge for. And what we found is, like, LangChain being not owned by IBM or a big company like this, and even AstraDB and all, we had to actually dig into it to find that they were owned by IBM, right? Because they're
Yes,
owned by
yes,
subsidiaries, and they're trying to hide it. They're purposely trying to hide it because they don't want you to know, right? If you know they own it, it kind of discourages your usage of it.
yeah.
They're
And,
pushing
and
you
it
to, like,
almost felt like some of the innovation and some of the air goes out of these acquisitions after they get acquired. And that's true, I think, for most specifically open source projects that have been around for a while. The founders get some money, they lose their hunger, which is not a bad thing. I'm all for founders getting paid, especially for open source project founders. But I think I don't know how to strike that balance. But anyway, Langflow became a nice side diversion for us. I think where we are today is Langchain, and Ollama. What else do we have? I mean, besides
we
that,
had we had the graph we had the graph database we used. We
we
used the
yeah
graph.
we
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 used the
have a
graph.
graph database.
It worked great with the actually, like, let's talk more about the graph database. Like, we came across a couple of tools for graph databases, but we actually decided to not actually dive into them at all because we saw Neo4j labs and we saw what they were doing and everything, and it was
Yeah,
like,
I mean, they're the premier sort of graph database provider. I think they're also one of the authors of that graph, whatever the I forget what the name of the language is for writing graph database queries. I think they have their own language.
okay,
So, and but they're a commercial company. They have an offering. They'll sell you a very fancy graph
and as
database.
soon as we saw it, we thought Databricks. We got like a little bit of, like,
I
that
think
Databricks.
we've gotten a bit burnt with all these offerings that are asking you for money right from the get go. So we said no, we can actually do this without it. So there's obviously lot of open source stuff out there. There's I think I don't know if Qdrint is a graph database or just a vector database, but we don't currently. Did we actually end up implementing a graph?
No, so what we did was actually we used it in the Llama model because the Llama models, even though it was okay, so initially we had Llama 737B and we were
Right.
using that, right? And the responses we were getting were quite muddled, and
Not that
we
great. Yeah.
and there was a lot of hallucination in there. So we were like, okay, it can't infer enough, right? And the
Yeah.
point of the RAG pipeline was we tried turning down the temperature, we tried turning down everything, we tried changing the system prompt, and nothing would work as good as the graph, graphing all the chunks. And once we created the graphs through the LLM itself, we used Llama to create the graphs completely. So, we didn't really need to do much. And the thing, what we found was very interesting that the first time it created it, it actually created it the best. And then we tried to create the graphs again, it was messing up, right? There was hallucination. And I think a lot of it was, we found out later that to do with Llama itself, like Llama 37B, because when we moved to Ollama and Langchain, and then we used Quen, the 8B model with
Yes.
the Quen embeddings, and we found it to be much, much better without any graph
Yeah,
requirement.
Quen truly was one of those eye openers for me. I mean, it really, I mean, complete with its sort of, I forget what it's called. It's got this introspection thing where it actually shows you what it's doing,
The
and
thought process, like the reasoning, yeah, it shows you
the
the reasoning.
reasoning model. So Quen's a reasoning model, and it really, really opened my eyes. And again, I don't follow this stuff as closely as a lot of other folks in this space do, but I thought Quen was quite eye opening for me, where it made two things very clear to me. Like I think for most applications, and I still believe this, you don't need an 160 or 270 billion model. What you need is a well structured reasoning model, maybe 8 to 20 billion parameters, and with a pretty decent solid context engineering side of things. So the context engineering to me is really where I think all the magic is happening.
I genuinely think the difference between the seven Llama 37B and the Quen 8B was very simply just the time it took to make a response. Llama was instant even on a CPU, right? The compute required for Llama was very little. Even though we got a G4 extra large as the instance
That's
on
true. That is
AWS.
true. You do have a point. I mean, we're still taking about 30 to 40 seconds. It's no longer 30 to 40 seconds, I think. Doesn't it come back within
Like 10
15 or
to
20?
15. Like it depends, it's also a lot
Yeah.
to do with what the journey is for it, right? It's referencing a
Yeah.
lot of documents.
Yeah.
I don't mind it taking a little longer. And our final, uh, agent when we created it, the thought process actually was very profound to me because it gives you information in the thought process which it might not answer, right? So even if
Correct.
it shows you that if I have 50% of the knowledge, or even if I have 80% of the knowledge, I'm not going to infer the rest of the 20%, which was a great
No,
breakthrough for us.
I really like that whole process. It helped solidify for me that this is really, I mean, it's literally like being able to see how the answer is arrived at, right? It's not a black box anymore. You can actually see how it's doing, how it's functioning. So, really enjoyed that work. I think that last piece was quite interesting for us. And then I think to me, the biggest Friday hack for us was we just managed to literally within 15 or 20 minutes build a front end. So we've been using Fast API because I'm a Fast API user. I've been using it for a very long time. So everything that we would build, we would basically, our end result was always an API, and we would invariably use Fast API as a front end because Fast API has this very easy to use UI that lets you send requests and get responses. We were using it, and then but because of I think I had Claude and maybe I had Claude Force on it on my cursor. I was able to
Yeah,
just
you had those credits which we were
I was
using.
able to literally. Oh, it wasn't. No, it wasn't ChatGPT 5. I think those credits were gone by then. I was able to use my Claude for my cursor credits,
Yeah, yeah.
which is
You
my
were
paid
using your
version of
cursor
Cursor
credits on Claude, and we
for
went through them quite quickly.
yeah,
Like,
yeah, but that's fine. I mean, that's life. But I was able to get the front end built, which again, frankly, is maybe like literally like asking everyone to build a like if an AI, if a coding agent can't build me a coding agent front end, then it should not be in the business of building
yeah,
coding.
it
It's
shouldn't
not
be.
like I was asking it to build me like a game. Even that
No,
games are
but every to its to like praise it a little bit, it actually gave us exactly what we wanted.
it
And
gave us
within
exactly what we wanted. It gave us, we wanted to basically have people score the responses with thumbs up, thumbs down, provide subjective responses. All that stuff was there. And literally within 20 minutes, we were able to deploy it, and it was live for a while. So I think that was a big sort of, I would say, that was a happy ending to that story. And I really, I think I enjoyed getting there because that meant that we've literally deployed something that is
and I think
well responsive. Yeah.
all of this was actually from like we couldn't there aren't many resources online, and we've seen Reddit also, like, everybody gets stuck and everybody's stuck somewhere, and like the thing is, everybody when they get stuck, from what I've seen, there may be more. I've only kind of seen probably 10% of what's on the rag Reddit and everything. And what I've seen is that everybody gets discouraged when they get stuck. And what we did when we
Yeah.
got stuck is we just changed. We were like, let's try something new. And we were
Let's
like,
try
why
something
not?
new.
Why
Yeah.
not? Like, we were
I
like,
think we would just open up a new tab on, either or a new thread with ChatGPT and say, look, let's take a step back. I don't want to do it this way because it's, this is going crazy. This is becoming a circle. Like I remember there was a few times when we really went down the rabbit hole, even with like on our EC2 instance, where there were some places where things were just not working. And I would just literally say either in the context window itself of ChatGPT, or we would open up a new thread entirely and say, I want to do this without any of the baggage. So we were very, I would say, disciplined about throwing away any experiment that
yeah, yeah,
came.
we didn't care starting from scratch. That's the thing.
We
We were
didn't
like,
care about
okay.
starting from scratch. Yeah, we were
And which
not.
is very important in the AI thing. Like, everybody now, and like, I think we've seen this quite a lot, is like, whenever it comes to technology, everybody's so, like, the sunk costs are the sunk costs. You have to
Sunk
accept them.
cost, yeah, the sunk cost fallacy is, I think everybody needs to let go. We just earlier today we had a call with your dad where I was pretty blunt with him. I said, look, don't get emotionally attached to any code because even if the code literally has been, it hasn't lost its polish and it's just been deployed, chances are
It's out of it.
it's already out of date. So let's not be emotional about it. Let's not get attached to any code. Let's treat it as if it was just a throwaway piece of code to be generated again. It's like a movie or an episode that's been put in the can. It's rolled out. It's had its run on Netflix, and now it's tapering. It's going into syndication. Let's not worry about it.
And a
So
lot of this is coming into the whole software engineering industry now. If you see it, like, I've seen a lot of it come up, and you see, like, junior software engineers are now just using GPT to generate code, and they don't care about Claude Code, or now they're using that OpenAI CLI with GPT-5, Codex CLI, it's called,
yeah,
with GPT-5. And the thing is, they're not really worried about creating clean code, because you don't need clean code, because you're not writing it yourself. That's the thing. And
that's
they were
right.
like,
Well,
you,
you don't need clean code. I think you need code that performs what it's been asked to do. So results matter more than actually the semantics or the clarity or readability even. And you need to have code you need to have solid guardrails around it. So I think the thing that I think is going to be required, and this we're going off on a little bit of a digression here, but I think software engineering is going to require developers to become very, very strong and powerful spec writers. So they'll
yeah.
essentially have to basically write not just the spec for how, you know, typically if you're an API guy, you write the interface spec. Big companies will enforce things like, build the data model, write the state machine. All that stuff is important. But I think now more than ever, you'll have to write not just that, but you'll actually have to write what's called the behavior format. So like BDD Gherkin is this language that lets you define how a specific software module is supposed to behave and how it's supposed to be tested. So you're effectively testing its behavior. And so,
It's
yeah.
it's in a way like what product it's like you have to work with the product team, like the product managers and the developers are now actually working very synonymously than more than before also because
Well, synergistically, and they're actually working in a much more, I would say, tighter coupling. That's how it should be, honestly. And in the
and
age
I
of
think some
AI,
of the
that's
product managers can actually create themselves now. That's the main thing which AI has been able to do, like.
well. Let's not go that far, because I will push back a little bit and say there are different types. There's a different skill set.
Yeah,
I think a product manager can and should be much more outward focused. They should be functioning more like the CEO of the product, right? And
yeah,
the engineering team, the engineering lead, the developer should be the one who's just literally the craftsman. So, like, this the product spec is the thing that actually needs to be totally well crafted, and it's a living, breathing document. We all get that, but the product manager's job is to make sure that he or she, the product is not getting lapped by competing products. It's meeting the, it's always right in terms of product market fit and all that stuff. The job of the developer is to make sure that the product is functioning repeatably and can actually, doesn't crash, doesn't have regressions, right? That's the job of the engineering team. I think these two functions should be split. They should not be the same person, because their motivations and their requirements are different, right?
yeah.
So,
True.
yeah.
Agree. I think it's evolving in a way that now with also Guinness, who you worked with so much, like we were having a conversation as well, and he was like that I that a lot of it is going to start becoming that the teams will work closer together because
Yes.
it's becoming quicker and easier to develop, and when it becomes quicker and easier to develop, that more ideas actually come to life. Like that's the thing, that what people are
Yeah,
envisioning comes to life
I
quicker.
agree, and I'm hoping for, and if it doesn't happen, then we'll build it. But I think what I'm counting on is the evolution of so think about the cursor ID. The cursor ID was loved by individual developers because it removed some of the boring work. So, like, it made their jobs easier by allowing them to say, okay, I'm going to have a little bit of AI assistance to help me, to help improve some of the work that I do that is truly, truly mind numbing. It's either basically walking through lines of error code, or looking at stack traces, or refactoring code, stuff that I can automate from within my context. I should be able to do. But I think the evolution of this tool and others in software engineering is going to be collaboration. So something that allows collaboration to happen, um,
Yeah, it's like a
not
team.
just
It's like a playground where everybody can put in.
playground, exactly, a playground where people can actually continually improve the product definition. We're sort of polishing the same thing, right? But we're working on different parts of it. But what I think will probably blow everyone's mind is if we can come up with a product that lets you do this asynchronously. By that I mean, you're basically just sending stuff into this thing, and the thing then is generating out the code. So you're not actually truly generating code. You're just basically
No,
emulating a script.
it's basically like putting every, like you're putting multiple different ideas into a bowl, and that bowl is
Exactly.
actually generating the code for you.
the
Uh,
the robots
I,
are the robots are doing the rest of the thing. It's like how in our fairy tales we used to have all these elves that used to come and make the toys at night, right? As we slept, and the toys would be ready by the
and then
morning.
then
So
then yeah,
that's
of course, to that point, like there will be a lot of questions, like it's a concept right now for us, and how it's working and everything, but like the thing is, one thing I think which will really help is if any of these agents like Claude or any of the large companies which are generating these LLMs and these coding different agents actually come up with a way to make it so they don't hallucinate as much. Okay, even if you turn down the capability slightly, or like you have because like Opus 4 is 6 trillion parameters, 4 point GPT 4.5 is 3 trillion parameters or something. The
wow.
model, as they get bigger, they will hallucinate. Like you can't
Yeah,
stop it from hallucinating, right? You give us a model which is smaller
yeah,
but more efficient in writing code, and I think a lot of small models, as you were saying,
yeah.
put
But
together.
but I want to come back to my comment here, and I think maybe you missed what I was the point I was trying to make. The point I'm trying to make is, if you think about everything in terms of asynchronous development,
Yeah.
Then the whole race of trying to increase your token throughput. Token throughput is how many tokens you per second are you processing, right? Everybody cares
Yeah.
about that
Yeah.
because they
Yeah.
want the responsiveness of your Q&A chatbot to be, I want to get my
Instant.
response. You said it yourself. Llama has to respond within 10 seconds or 5 seconds. Our Q&A chatbot needs to be, that's a very customer focused, end user focused
And focus.
problem
Yeah.
that you're trying to solve. Now imagine if you turn the problem on its head and you say, look, I'm a software engineer. My job is to complete the spec. I'll write the spec, I'll upload it, and I'll go to sleep, or I'll leave for the day. Now, whether this agent is processing and generating the code, and I'm giving it a, let's say, a 10,000 token context window or a 100,000 token context window, it doesn't matter what the token throughput is. Let's say the token throughput is 100 tokens per second, so it ends up taking 1,000 seconds, right?
Yeah, it does. Yeah. Yeah.
Who cares?
No, no,
I don't.
I completely agree with you. I was just coming to the point of also, I got that completely. And I was like, saying more to do with the hallucination. Like, right, if you give me a
Yeah.
smaller model like we had with Quen, right? Quen is not the largest model at 8 billion, but because it's a reasoning model at 8 billion, it takes slightly longer. I was saying that if you have models which give you more reliable outputs, right? Or you get whatever spec you've given, if it's more reliable in creating the code for that spec, even if it takes longer, as you've said, because it's
Yes.
doing it after hours. The thing is, you care more about reliable outputs. That's why we liked O4 Mini High more than O3,
Right.
even.
Well, and so, but the last part about the reliable outputs, really, in my view, my position is reliable outputs, I don't think will come from more parameters,
No, no, it
a
won't. It
higher
won't.
parameter
Not at
model.
all.
They'll come from a larger context window. So if you give
Yes,
it a
exactly.
well-defined spec and you give it guardrails that say, look, don't do this, absolutely don't do this. And by the way, everything you generate has to pass these 5 acceptance criteria, then you are less likely to have bad output or hallucinate, what we're calling
I
hallucination
think
or bad, thing being
completely,
generated.
completely. And I think the way to do it, like what we found from our work together, is like, no matter how much you tell the model that don't do this, it will still do it. Like, when we asking, can it take my dad to Tambola? Can the caregiver take my dad? Even though we told them specifically not to think about it, not to do it, it still infers. So I'm
Well,
saying
but
that
in the end, I think Quen's only like an 8 billion model and it never failed us. I don't
no,
know
it didn't.
why, but
But we turned the temperature
Quen,
down to zero. Like I think it was the mixture of the reasoning model with the zero temperature to where. But I think you
maybe you're
needed
right.
that reasoning.
Yeah, yeah. I don't think we went back and increased the temperature, so I don't know if that's entirely true. I just thought that maybe because it was a reasoning model, and maybe it's designed to be less psychophantic and a lot more direct. Maybe it's Chinese. Who knows? I mean, I'm not again. I don't want to sound bad, but that was
No,
my
no. I mean,
conclusion.
they've done it in a certain way. Like the Chinese people do have a certain way of developing things where it's very to the point. It's very
Yes. So
serious.
maybe
It's like
it is a cultural thing, Maybe it's just
there is
designed to
less
be a
there
lot
is
less
less
psychophantic.
there is less, what do we call it, there is less chances of them wanting to please more people, right? They want it to be as useful as possible, right?
Yes, yes,
Quen
yes.
the
So I wonder if we've uncovered that there's basically like a national character, depending on where the LLM was
yeah,
built,
like
wherever
Google
the
Google
frontier
is
model came
maximum
from.
psychophancy. Like Gemini is as psychophant as it gets. Like Google will agree with everything you tell it. To a point also, like, there are roles for all of that. Like I don't think
Yeah.
it's a bad thing to have psychophancy. It's just that it's not our use case, right? Psychophancy might be great as a companion agent or something where they want a friend, or the people do deal with loneliness and they turn to LLMs, or they want advice and they want to feel heard and stuff. It does have its own role, but it doesn't
Yeah.
have a role in a place where it is used for development. And certain models, let's say the thinking models, or the models which are actually higher in compute, or which are actually being placed as premium models, don't need that psychophancy, right? They don't need it. They need to be more actually toned down in temperature and actually more useful, as we put it, to creators, right?
Yeah.
Because right now, if you give me a model with more parameters and higher psychophancy, it's not really going to be useful to me as much as O4 Mini High. And we saw O4 Mini High be so good because it was smaller than O3 and GPT-5 thinking and everything, but it also had lower psychophancy and stuff. It was predictable, as you
It
call
was
it.
predictable. I think predictability. I think is the key to adoption in my view, and I think the key to predictability, again, from where I stand, is not we don't have to create a frontier model. In fact, we can have a less parameter model, because I don't care as frankly about as much about token throughput, because the use cases I'm building are largely asynchronous, maybe not necessarily user facing. And if you have an asynchronous use case with agents maybe talking to each other, or even humans basically sending like essentially like if you're willing to basically have a response time that is not a chat response time, but maybe equivalent to an email response, right? Like people don't expect to get an email response within seconds. If you get
Yeah,
an email
exactly. You
response
you
within
can wait half
24
an hour,
hours,
you can wait an hour, you can
you
sometimes
can
wait
wait
a day.
24 hours for an email. So if
Yeah,
the
yeah,
email, if the response expectation is closer to the email rather than a chat, then I think it's really all about context, 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 and strong guardrails, which is part of the context.
yeah. I also believe a lot of it is to do like what we were thinking, with our vision of all of this, with how it should actually empower you in your off time, right? It should allow you to work less.
Yes.
It should allow you to monitor rather than to, okay, there are tasks in our daily lives that we don't like doing, but we have to do. Like,
Yes.
like when you get into work, you have to check certain things, you have to go over certain manuals. Even though you don't want to at that point and you know it well enough, there is certain things that change, right? Like, and you need to know certain things. And in that way, this actually just enables you to do a lot of the work and just come and oversee it, right? There is a
Yeah.
lot of things where you're bouncing ideas off walls, and this lets you automate it overnight. Like you want to sleep on something, and the next morning you come and you've got some semblance of a working prototype, or your ideas come more to life than you could have imagined them being. Like it's like
Yeah.
putting pen to paper in a sense, but automatically.
No, no, absolutely. I think this is about having your own personal mundu slash minion. Do your work while you sleep, but not sleep because you're lazy. It's just that I think it's better for you to sleep and wake up refreshed, so you can actually have a whole new set of ideas and thoughts, and you can review the work much more efficiently. But the scut work is being done by an agent. So I think
But
that's
I
that's
think,
really that's really
and
what's
yeah,
animating.
that's what you need. Like, okay, all of these AI use cases are great. Like, having a chatbot is great, having all of this is great, but it needs to actually make your life easier. You don't want these things to work harder. Like, you are working harder, but you're working harder on things which matter, on things which require more time. Like, idea generation, actually oversight of what is important, like rather than thinking about, okay, this line of code I need to write in this way, or I need to write this now, and this is going to take me this much time, and then if this idea comes up I need to write it, like spend this much time writing code again, or asking an LLM to do it for me, where
Yeah.
it bounces off each other. There are things, I mean, right now we'll have to prototype it and see if
Yeah.
somebody comes up with it and make it, but essentially it's just like enabling you to live a better life, which is what AI actually came to promise right at the
It's
start.
supposed to do, right? I mean, let's hope that it lives up to the promise. But I honestly feel like it's up to us, right? I mean, we have to invent our future. So rather than let somebody else tell us, or the big companies tell us how we should live our lives, I hope the future we're heading towards is not a Ready Player One type future. It's more of a, I don't know,
I think
more
I
of
think
more
that's
of a
fading out a little bit.
Star Trek future.
I
Sorry.
think it's fading out a little bit, and as you're seeing it, like, because LLMs are here to stay in whatever capacity they are at right now, and they will keep growing because people will keep investing in it, and everybody wants to be number one, and everybody wants to be the number one LLM. And I think we have a couple of years till that fight is going to settle down, and we'll see a definitive winner. But in that time, we can leverage any LLM, whichever suits us best.
Yes.
It's not, and we build it open to,
Yeah, the
and I think,
design. Yeah, it has to be an open design, right? It's literally like how for the longest time Macs only ran on PowerPC, and that was a huge problem for them. And then they eventually figured it out that they needed to basically switch to x86, which is the processors that
yeah,
the world's PCs used to run
yeah.
on. And that was one big change they made. And the other is they threw out their entire OS 10 was based on BSD Linux, which is an open source system. So they made some hard decisions, because they back then nobody was like, that was literally like saying they had standardized on one LLM, and it was really hard for them to rip out that LLM and put a new LLM in. But I
And
think any good design right now needs to be completely agnostic to LLMs. LLMs should
and
just be like a
that's
chip.
that's the thing completely, like, and that's what the whole AI industry is. You can't get stuck on what you built
Yeah,
because it changes so quickly. You have to be ready to give it all up and start again, because if you keep holding on to what you have, you're likely to go backwards, like, and we've seen it happen. Like, you have to be open to change, and you have to be open to, because a new LLM comes out every day, like,
yeah.
the new Google image generation one, Nano Banana. It's very good. Like, I don't think you've had a chance to see it, have you? None.
No, but I mean, I will. I'm sure at some point. I'm sure you'll
Oh no,
show
so
it to
it's
me.
all over Twitter. With I get 90% of my
I think from the next episode, because we're going to run out of, I'm running out of time. I have to go and jump to another call. But I think for the next episode, we should maybe devote like at least 10 minutes to some cool things that we've read or talked
yeah,
about. So
we've read and everything.
we can
Yeah, so
just
let's cut this off at what we had in AI today, and give it our thing, and, like, let's talk about what we want to do next and how we're going to evolve this, and
yeah.
you
So
know
I think where I think we're going to go next is we're going to continue to explore. For starters, Vesta is going to be our next big project. We're going to be working on adding agentic workflows on top of the existing system and making it much more useful and powerful. Ultimately, we want people to use it. So that's the commercial side of things. I think personally, what I'm really interested in doing is exploring more of the memory and context side of the agentic world. So building systems where I get really good at figuring out how to not only prune but also refine and improve the memory that the long-term memory that any agent has. I think that's really an interesting side part of
yeah, and we'll completely be
AI.
working on that, and discovering that more. Then take you guys on the journey with us, but
Yeah,
on how
yeah,
we're doing everything. But I think next episode, we'll actually probably actually spend more time, talking about what's actually happening. And this was just an introduction on what we've done and how our journey's been and what we've actually discovered, and our thoughts more of it. And I think more than
yeah.
AI,
And,
you'll see this
and
evolve into more things and more
absolutely.
topics.
And I think the cadence we've not truly decided yet, but I think the point is when we feel like we have enough raw material to generate another episode is when we'll actually generate the episode. I don't think
We
there's
just
any
wanted to
compulsion to
start.
record because then you'll just basically have a lot of quality with quantity with a lot of without a lot of quality. I think our endeavor and aim is going to be to only record when we have something useful to say. So this is episode one of many, but I can't really predict when the next episode is coming.
And we try everything, and it was Sid's
And we're
idea to
doing
start this.
and yeah, and I think
And
our vision is we want to continue to learn by doing. So everything that you hear and see will be completely unfiltered feedback from us butting our head against any wall and every wall out there, and we're doing this so you don't have to. And that's kind of the reason why we're recording this.
we actually want to understand what this industry has to offer, and many things more. Like, we start with AI and technology, but there are a lot of other topics that we are fond of, and we'll probably bleed those in. But, like, as what our motto is, we're not scared of trying anything, and there's nothing that holds us back. So we will continue trying to add more things, and discover more, and we hope you like the first episode.
I hope so too. Anyway, we've enjoyed recording it. I think I've really enjoyed recording this. So I hope you like at least listening to it on 1.5x speed. And we promise we'll create some shorts with some highlights. I'll leave that to my very able co-host,
Okay,
Gupta.
thank you guys. Have a great day and a great week. We'll see you soon.